Hello everyone, welcome to this video. In this video, I'm going to be showing you how to access the cloud server where we will be doing all our statistical analysis. The cloud server is called Posit.Cloud, and it hosts an app called RStudio, um, which is used by most statisticians when they do computational statistics. So here we are on our homepage. To access the server, for the very first time, click on first time opening RStudio. You can just click on it. I'm going to open it in an incognito window so I can log in with a different account. But again, you just click on it normally. So when you click on it, you should be taken to a login screen like this. Make sure you log in with Google. Don't log in with your email. Log in with Google instead. And you can just log in using, in fact, you should log in using your Chemeketa email. Don't use a personal email, use your Chemeketa email just to keep everything simple. That should take you to your single sign-in. And you may have to enter in text, code. And once you do, it's going to take you to the Posit.Cloud server, and it's going to deploy a project, and that might take 30 seconds or so. So just wait until it's fully deployed. Here we go. This is RStudio. It's a cloud-based app that runs a program called R, which, as I said, is where most statisticians do their statistics. So the first thing I want you to notice is it says temporary copy up here in flashing red. Nothing you do is going to be saved if you use a temporary copy. So the first thing you have to do is click Save a Permanent Copy. Just click on that, and now you will have a permanent copy and no longer says temporary copy up here. This is RStudio. RStudio has a series of small windows that fill the screen. This window here on the left is the console. This is where you can do basic calculations, treat it as a calculator, 2 times 5, or you can do more complicated statistical calculations, like if you want a mean of a data set, it'll tell you the mean of the data set. Up here on the upper right is the environment. This is where R keeps track of any variables that you create so you can use them later. And it's also where your data set has to live. Now, right now, when you first open R, the environment is empty. And so you need to import your data into the environment. I have loaded all 3 data sets onto the cloud. And so you just need to click on the one that you choose. Each lab should use the same data set. So for lab 1, you're going to pick if you want to work with climate data, health data, or salary data. And once you pick it, just click on there and select Import Data Set. You might get this error pop-up window, but that's not an issue. Just click OK, and then click Import. And now you can see your data. And also notice here in the environment, it has now loaded the data into your environment. So now you can actually work with it. This data will stay in your environment for all 4 labs, so you shouldn't have to import it again. Here in our cloud, we also have 4 scripts, one for each lab. So click on the lab 1 script and it will open. And this is where you will copy and paste the code from the code and output document, and then you will run the code. And I'll show you how to do that in a minute. Labs 2, 3, and 4 are also pre-built for you. And I also created this script called a sandbox for homework questions. This can be useful because some of the online homework questions are most easily answered using R instead of using a calculator. And so you can use R and keep all your code here. And there's a list of generic commands on Canvas under the online resources. So notice when I type in my code, if I press enter, that code doesn't actually run. If you want to run code, once you type it in, you click the run button, and then it pops it down to the console and runs that code below. If I want to look at the standard deviation of the same data set, I can type in SD of that data set, and when I run it, it runs there below. So the script is really useful for organizing all your work so that you can run it logically. Okay, back to lab one. This has concluded our introduction and our orientation to access Posit.Cloud. I will show you how to access it for all the future times, and then we'll use that, and I'll give you an intro on how to start the first lab. So here we go. I'm going to say I'm done with this for today, so I can just close the window. And now if I want to come back to it, every other time you open our studio, make sure you click this link here. That will allow you to get back to your workspace instead of the temporary copy workspace. So again, you can just click on it. I'm going to click on it using an incognito, but you can just click on it normally. It's either going to take you to this page or it might take you all the way to your workspace if you're still logged in. Make sure you log in with your Google and you use your My Chemeketa email. Okay, so this is now every other time I'm logging in. And this is going to take you to your workspace where you'll see your content, and there's that project there that we started. So when you see this workspace, you just click on that link and it'll take you back to your project. Here's the lab one. Notice the climate data is still uploaded. It even kept everything in my console from before. All right, so that's how you get back into Posit.Cloud and RStudio. Now let's suppose I want to start on the first lab. So I'm going to go here. So scroll down to our week one module and you'll see the lab one right there. Click on lab one and it gives you this information. There are 3 topics for the labs. You're going to choose one of those topics and stick with that topic the whole term. So I already loaded the climate data, so let's use a climate data lab. Again, you just click on it. I need to open it in an incognito window so I can open it under a new account. The first thing you need to do is you need to make your own copy, because that's what you're going to actually be filling out. So we've made our own copy. Here's Stat 243 Lab 1. If you're taking an online course, you may be working on this on your own. If you're taking this in class, you may be working with someone else in your group. So general lab instructions. Each lab has a code and output tab and a report tab. You will have to submit both of these for credit. The first thing you do is first you work through the code and output tab. And when you're all done with that, you come back and you fill out the report. And so I'll show you how to do this. We've already completed step 1. We made a copy of this lab template. Good job. On the first lab, I ask you these questions so I can get to know you a little better. This is a link to the tutorial video we are currently watching. You can navigate to login.posit.cloud or go through Canvas. Okay, so now we start seeing some of the code. Everything that's code is written in this computer font. And so anytime you see it written in this computer font, you're going to be copying and pasting this code into R. So I'm going to copy this. You can right click or you can Control C or Command C. And then I'll go back to Posit.Cloud, and I'm going to put this code right there. Stat 243Z Lab 1, put my name and the date. I'm making this video on the 16th. Okay. All right, so this code, notice it's green and it has a hashtag in front. That means this code is comments. It's just for humans to read. The computer will completely ignore it. You can run it if you want. If you ever want to run a block of code, highlight everything, and you can run the whole block of code. And it will run it in the console, but it's not doing anything. It's just printing it for you. So let's go back to our copy of Lab 1 template and go to our first question. Question 1, introducing the climate data dataset. What variables are contained in the dataset? Copy and paste the following code into your R script, then run the code to learn the names of the variables. So we'll copy this and paste it here. And notice, since my cursor is on line 17, I can just click run, and it's going to show me the names of the variables: continent, country, city, April temperature, April precip, and latitude. Copy the output and paste it back in the lab here, and we've answered question 1. Notice that question 1 has this highlighted report. That means the results from this question are going to be written in the report. Most of the questions in the labs relate to the report. Some of them don't. So you'll notice there are some questions, like question 2, which asks you to construct a relative frequency table. So you need to do that in the code and output, because that's a skill I want you to work on. But it may not be necessary if you were writing a report. So it doesn't say report, it doesn't have to go into your report. All right, so here we are, step 4, dataset overview. Question 2, copy and paste the following code, and then run both lines of code to count the number of cities in the dataset. So I'll copy this and I'll paste it here. I can run the code one step at a time. When I click run, you'll notice the cursor runs line 19 and then advances to line 20. Now, when I ran line 19, it didn't give me any output. But over here in the environment, it did create a new value, a value n. And now when I run the code for n, it's going to tell me n is 193. But I can copy it, or I can just come back here and say, what is the number of cities in the climate data set? They're 193, et cetera, et cetera. I'll do this last one. What continents are represented? So I'll copy it, I'll paste it, and I run it, and then it gives me the list of the continents. I'll copy it and paste it back here. A couple things about the code and output section. First of all, class is not focused on coding, so I have written all the code for you. Usually a statistician will write the code themselves, or this day and age, they might tell an AI bot, this is what I want the code to do, and the AI will write the code. But since this course isn't focused on writing code, I've written the code for you. This course focuses on interpreting analysis. So we now have a list of the variables. In the code and output, you can leave it unformatted. It can just be this list in this funny font. Right here, my listing the continents, not formatted very nicely. But when you go to the report, it should be written as a report that someone would actually want to read. So for lab 1, you go through step 5, all the way down through step 6. I must have skipped it. There it is, step 6, quantitative analysis. You copy and paste the code, you copy and paste your output, and you will end with a nice full document full of useful output. And then you're going to take that output and write your report based on that output. As I mentioned in the statistics rules of three of the main things that statisticians do is they collect data, they analyze data, and then they communicate the analysis. And I've collected the data for you. You're doing the analysis using R, and then you are communicating the analysis in the report. Let me just move ahead briefly so I can show you. We'll put a little more content in here. So here's our create a table, copy it, paste it. Your cursor has to be next to the line. If your cursor's down in the console, nothing's going to run. Oh, it did run. Well, that's good. But you might run the wrong line. So it's best to make sure your cursor is exactly where you want it to run. Here's my table. I can copy it, paste it back. You can just delete this and put it there. This is a pretty poorly formatted table. Africa is, I think, associated with 15, but it's kind of hard to make that connection, right? Asia, Europe, North America. I don't even know if that's right. Let's see. Yep. So you would never want to just copy and paste this table into your report. That's almost impossible for someone to read. And then I'm going to jump forward and I'm going to do the bar plot as well, just to show you how to copy and paste images. So let's copy the bar plot, put it here, run it. And over here on the right, it's produced the output. It produced a visual. Now, if your picture is too small, you can increase the size of this little window to make it a little bigger. And in fact, one common challenge is, especially if you're minimizing or if you have a small window like this in general, if you try to run the code, it's going to give you a warning message which says in do, try, catch, return expressions, et cetera, et cetera. It couldn't make the picture because your window's too small. So make sure your window over here in the lower right is big enough that you can actually see your picture. Some of the words might be cut off, like North America and South America. That's okay for this class. There are ways to make visuals look super pretty, but it takes a lot of coding, and this is not a coding class. To copy the picture over, I recommend just right-clicking and copy the image. If you just right-click and copy the image, then you can go back here, delete that, and paste the image, just like so. Okay, let's suppose we've gone through the whole code and output. We've run all the code, copied in all the output, answered other questions, like what is the number of cities in the climate data set? There's some other questions in here that ask you to, for example, do you prefer the table or the bar graph? What is one thing you could add to the bar plot? I want you answering all these questions. Not all of them would go into the report though. So I've completed the code and output, and now I'm ready for the report. So the report is designed for you to practice writing an analytical document that you would actually write if you were an intern at some kind of organization, either a climate research lab or a health clinic or an economic consulting firm. I give you a lot of direction in these brackets, so you should be reading these instructions carefully. This one, for example, says choose a title for report. And this one says list your name and any collaborators as authors of the report. Anything in brackets, ultimately you should delete or replace with your own work. The bold headings you can leave to help you kind of orient your different work. So the introduction says introduce your report. Your introduction should include the following: the scope of the data, is it local or global, the variables of interest, the purpose, and the audience. And here's an example using salary data. Of course, I'm writing on climate, so I'm going to replace this with something that is more climate focused. In the data overview, you're going to describe, not just list, the variables included in the data set. Well, in my code and output, I found what the variables are. They're these ones: continent, country, city, April temp, April precip, and latitude. So in my report, I would say something like, The variables included in this data set are the continent, country, and city where the measurements are taken, the average maximum temperature, I think it's the average temperature in April. It's the maximum. It's the average maximum temperature in April. Degrees, you need the units. I'm not going to answer that question for you. You're going to figure that out. And the total precipitation in April. Make sure you have the right units. There is also an indicator of the latitude of the city. Right? Quantitative variables include units of measurements. Qualitative variables should be contextualized. How many observations? So we figured out there are 193 observations, which are cities in this data set. And the time period is limited to the month of April. There are cities from each inhabited continent, although some continents have more cities than others. Right? I think that's pretty good. Maybe not perfect, but good for this introduction video. So now that I've read this and I've checked and I make sure that I've talked about all the pieces in here, I delete it because this is a report that I'm going to hand into my supervisor. Geographic identifiers. In this section, you should describe key qualitative variables. You should include and interpret tables and bar plots for more complicated variables. So for example, it suggests continent. So if we go back to the code and output, here's my table with the different continents and the numbers of cities per continent. And if I just copy and paste that in, that's a terrible table. That's really poorly formatted. The text is hard to read. Africa doesn't line up with 15, etc. Right? So you're at the very least going to want to insert an actual table. I think there were 6 continents. And format it etc. All right, so don't just copy and paste the output into your report. It's fine for the code and output because that's just organizing your analysis, but in the report, you're communicating it. And it might be useful to look at a bar plot, so I could put the bar plot here. In this case, it's okay to just copy and paste the bar plot, even if some of the words are cut off. Just make sure it's big enough to read, but not so big that it takes up too much space. So you're not going to be able to edit this part of the bar plot, etc. Okay, you're going to describe this, right? Make sure you answer all the questions. And once you've done all that, you can delete this section and then move on. And that's how you fill out the report. When you're all done, you can go to File, Download as a PDF. And when you download it as a PDF, you're going to download all tabs. And if you download all tabs, then it will create a PDF that has a code and output followed by the report. If you download one tab at a time, that's fine. You just have to upload both of them. So let's take a look. So it just gives me the code and output first, and then it gives me the report. And here's the report with my changes that I put in here. And then you'll upload that to the assignment right here. Okay, you can view the rubric Basically, I want to see that your quantitative analysis and your qualitative analysis, your visualizations and your reports, your visualizations are all there, and that the report has answered all the pieces of information I ask for, and that it's written in a professionally communicated way. All right. Let's see. Back here. When you're all done with this, you can just save it to make sure it's saved. It looks like it did an autosave. And then you're all done. Thanks for watching this video. If you have questions, you can ask me in class if you're an in-person student, or you can put a question in the discussions. All right, thanks for watching.